Cool. So yeah, I'm going to be talking about the model upload and model catalog parts of DAFNI, which so we're on the same screen that you saw earlier. Bethan's already talked about data, and I'm going to talk briefly about models and workflows on DAFNI. So to do that, I'm going to guide you through the model upload process on DAFNI and how that all works. And the model that I've chosen to use for that is the COVID-19 model from Imperial College London. So if you look through this repository, it's fairly complicated for someone to figure out what's going on, how you actually go about running it. For a non-technical user, you probably struggle quite a lot in getting it to run. And so one of the benefits of DAFNI is that you can bring that model on. One person does all of the work to convert it and make it DAFNI compatible. And then it's available for anyone to be able to use and change the parameters and link it into other models, that kind of thing. So that's one of the benefits. Another one of the benefits is this model itself takes something like half an hour to run, but it uses up 30 gigabytes of RAM, which typically you wouldn't have on your laptop or desktop machine. So you would struggle to run it on your home PC, regardless of actually being able to get it to run in a technical manner, but you wouldn't have the hardware required to be able to make it run as well. So if we go and look at the model catalog in DAFNI, this is where we can see all of the models that have been uploaded onto the system. And if we go back a while, we can see some of the pilot models that Brian talked about earlier that was uploaded a while back when we did those pilots. And so they're all available for our users to go in and look at. But also we now have the capability for people to be able to add their own models. And so all you have to do is click this Add Models button. We've even got documentation available to describe the process. But essentially what you need when you upload a model to DAFNI is you need a Dockerized image of your model, and Docker is just a way of packaging up your code so that it can be shipped off somewhere else and run in the exact same way that you run it locally. And so it guarantees that what you're running locally is the same as what's running on DAFNI. So that's the first thing that you need. And the second thing that you need is a model definition file, which is essentially just a YAML file format, which describes all of the input parameters your model can take, all of the metadata around it, such as the description, the summary, and the title, and that kind of thing. We have extensive documentation available on how to write your YAML file and also how to create your Docker image as well. So in this scenario with the COVID model, I've done all of that Dockerization process. It took less than a day to sort of put that together, having had no knowledge of the code base. So for a technical user, it shouldn't be too difficult to do. So if I go and look into here and find the COVID model, I've got this tarball, which is essentially just a compressed version of my Docker image, and I've got the YAML file, which is the metadata about my model, and I can put those into there, click Add Model, and then we could wait for it to upload, but it's going to take a bit of a while. So Blue Peter style, I've done one earlier so that we don't have to watch it upload. So that wouldn't take too long to do, but it's just obviously not that interesting to watch that happen. But this is what you can see as a user. So if the COVID model has been shared with you on DAFNI, for starters, when you upload a model, it's only available to the person that's uploaded it, but then they can choose to upload it with whoever they want to. But once you've got access to it, this is the kind of thing that you can see. So you've got a description of it, you've got a list of the parameters that it can take and the minimums and maximums of those parameters, as well as a list of the output files, which show some sort of explanation about what will be outputted by the model. So you've got an idea of what you can expect in that regard as well. So then if we go into workflows, this is where this is sort of the meat of the modeling system, and it's the place where you can come and run your models, link your model into other models in a system of systems approach. And so if I just quickly go into create workflow and enter some sort of dummy values for now, build. So this is where you can come and build those steps up. So we have 4 different step types at the moment. we've got an iterator step type, which will essentially loop over the same step in your workflow multiple times, but it will change a certain parameter by either a random amount or a fixed amount. So you can increment, let's say, the R number by 0.1 each time, and you can run that thousands of times. And in the back-end system, it will actually run in parallel. So that sort of iteration can be run much more quickly than you would be able to on your local machine. We've then got the model step, which is this is where you actually like input your model essentially, and so you've got all these different models to choose from. I'll choose the one that we uploaded before, and then you can actually go and change the parameters within that model. So I've exposed some of the parameters that the actual model itself exposes, but not all of them, because there was a list of hundreds kind of thing. But you can change things like the R number, you can change the percentage of people that are actually complying with the quarantine rules, how much time the government recommends that you isolate if you suspect you've got COVID. So you can change a whole bunch of different things, as well as the country. As I said before, running for the United Kingdom takes about 30 gigabytes of RAM, and usually lasts about half an hour on a decent machine. Before I uploaded it onto DAFNI, I was only able to get it working on my local machine for Hawaii, because that's all I had the resource to run for, because it's such a small country, I suppose. So then we give that a name, so we call it COVID, and create that step. So the next two types that we have, one is publisher, and this will essentially take all of the output data from that model run and upload it into the data catalog that Bethan showed you earlier, and you're able to specify your metadata for that as well. And hopefully, well, it's already actually on the staging platform. This is exactly the same as the metadata input that Bethan showed you earlier. This is sort of the old style of doing things, but hopefully someday soon we'll get the maps up here and you'll be able to choose the spatial coverage of that kind of thing. So you'll have really rich metadata coming out of that model. The other step is visualization. So this allows you to spin up a visualization builder, so that you're able to take the outputs of your model and do some kind of visualization on them. And so this is the one we're going to pick for this example. At the moment, the only visualization type that we've got is Jupyter Notebooks, which I'll show you in a couple of minutes. But we're hoping to add way more visualization options in the future. So we're currently working on a drag and drop interface where you can essentially just take your output data sets. You can choose what gets put on the X and Y axis, for example, and it'll automatically make you a plot. You could then export that plot and share that with other users. And so you can really see rich outputs from your model and visualize them all in the sort of sphere of DAFNI, which is really cool. So then again, I would have to fill in all of this metadata to show more information about the output files. I then choose which step I want to include the data from, and then I would type in a file path to that data. Again, all of this will be automated someday soon, so you won't have to do this part. You'll just have to specify which step you want to include the data from. But you can see how this system could be used to add way more models. So if, for example, I've got the COVID model as my first model, I might want to see how that's going to impact demand for housing. So I select a housing model and choose some more parameters in here. You'd have to have some kind of intermediary step to convert the outputs of the COVID model into what the housing model expects as its inputs. But you can see how quite quickly you can build up really complex system of systems models in this workflow builder tool. So once I've built my workflow, I just have to click execute here, and that would start one off. But again, that'll take about half an hour to run. So I ran one earlier on, and this is what you'll see once you've got a successful workflow run. So you've got these ticks to show you that the steps have completed. And in this scenario, I did the COVID model, and then I went straight into a visualization step. And if I click on this visualization button, I'll load up into my Jupyter Notebook. So this is a Jupyter Notebook environment, and for those not familiar with Jupyter Notebook, it essentially allows you to write Python or R code in this web browser essentially, and then it'll also compile and run it for you as well. So the idea of this at the start of things was to actually give users a way to write some code to do some visualization of their outputs. Obviously, that's not ideal for non-technical users. They would rather use a drag and drop interface, and so that's what we're working on currently, and hopefully that'll be ready in the coming months. But fortunately, the GitHub repository did have a bit of R code in it to actually draw some visualizations. So all of my data outputs have come in, so you might recognize these from the metadata that I showed earlier. And now I've got some R code here, which will essentially just do some visualizations of that data. So if I press run, I've then got some output graphs, and I can see all these different interesting outputs about this COVID model, which estimates how many people are how many cases they're going to be, how many deaths they're going to be, that kind of thing. And so you can see how you could use this Jupyter Notebook to do some post-processing on your data and then draw some nice graphs as well. But yeah, that's about it for my demo. So I'll pass back to Marion.